EET 114, Chapter 15, Series Circuits. This is Series AC circuits. So this is the introduction of the block diagram. So if you have different elements in the circuit, you're going to replace them by a block, which would be their impedance. So this is an RLC circuit, and you could just put a box in there that represents an impedance, okay? It doesn't matter if it's an R, an L, or a C, you could still represent each one of them by an impedance. Resistive elements. The book uses bold type for phasor form, which has a magnitude and direction. Um, Sometimes I'll draw a little hat with an arrow or like a caret symbol above to represent a phasor, which is also a vector. So ZR is the impedance of a resistor. It's equal to the magnitude of resistance, which is R, and a phase angle of 0. And the voltage across it is in this form here. Okay, so if we're given a voltage across the resistor in the time domain equal to V sub m times sine of omega t plus theta. I'm going to use theta or Q because Q is the Greek symbol in the symbols font for Excel for phase shift angle theta. From here on out, so Q equals theta equals this symbol right here. So VR, the voltage across the resistor in the frequency domain, which would be the phasor, is Vm, which is this amplitude, divided by the square root of 2 with a phase angle of theta in degrees. I sub r is going to be V sub r divided by ZR. ZR is defined to be this, equals I, I is the magnitude of the current in the phasor form going through the resistor with an angle of theta. And then I sub r, going back into the time domain, is the square root of 2 times I, this I magnitude of the phasor, times sine of omega t plus theta, which is equal to I sub m times sine of omega t plus theta. So I sub r is the current through the resistor in the time domain. Likewise, for inductive elements, V sub L equals V sub m times sine of omega t plus Q, which is theta, where V sub L is the voltage across the inductor in the time domain. And then when you convert to the frequency domain, which is the phasor domain, you have this V sub L equals V sub m divided by the square root of 2 with a phase angle of theta in degrees, which is also equal to just V, representing the magnitude of the phasor, this phasor V sub L angle of theta. And then X sub L is the reactance of the inductor in ohms, and that's equal to omega, this W from here, from the sine wave, times the inductance L, which is also equal to 2 pi f times the inductance, since omega is equal to 2 pi f. And then I sub L equals V sub L divided by X sub L. This is just Ohm's law, okay? You know, V equals IZ is the new version of the Ohm's law in the AC for AC circuits. X sub L is a form of impedance, which is called, when it's purely inductive or capacitive, it's called reactance, okay? And this is the reactance of the inductor in ohms. So then you just do the math this way with V sub L divided by X sub L. So it would be V angle of theta divided by XL angle of theta L equals V divided by X sub L. You take the two magnitudes and divide them, and then you take the phase angle Q minus 90 which is a definition for an inductor. Yeah, because the inductor reactance is in the denominator, so you're going to take that phase angle Q and subtract Q sub L, which is theta sub L, which is it's going to be 90. And then I sub L then is equal to angle of theta minus 90. And then to convert this back to the time domain, I sub L equals the square root of 2 times this magnitude times the sine of omega plus theta plus 90, which is then I sub m is the square root of 2 times I sub L times sine omega t plus theta plus 90. And then z sub L is equal to x sub L is equal to the magnitude of XL with the angle of plus 90. So that's the definition of a of an inductor. Likewise, you have a capacitor. V sub C is the voltage across the capacitor, and then you convert this sine wave to this phasor by taking this and divide by the square root of 2. Take the same phase angle, so that equals V angle Q. And X sub C is the reactance of the capacitor in ohms, equals 1 divided by omega C, which is also equal to 1 divided by the quantity 2 times pi times F times C, the capacitance. And then doing Ohm's law across the capacitor, I sub C equals V sub C divided by X sub C. And you can do the formula, the phasor math that way. So V angle of theta divided by X sub C angle of theta C, you take the V divided by the X sub C angle of Q plus a 90, because again, the definition of a capacitor is X sub C angle of negative 90. So if the negative 90 is in the denominator, you end up adding it here and then convert this back into the time domain. I sub C equals the square root of 2 times this magnitude, I sub C, capital I sub C, times sine omega t plus C minus 90. That equals the maximum value of the sine wave, I sub m, times sine omega t plus theta minus 90. So again, capital letters are representative of a constant, of like a DC number. Lowercase letters are the sine waves, mean that they're in transition dependent on the time variable. And then the capital letters, or I'm sorry, the bold letters are phasors. That's just how the book does it.